everyone. Uh, First thing I'll do, I will allow everyone to talk. Okay. Also, the chat is enabled. So if you will have any questions, if you will want to ask anything, let's begin. Thanks for coming, all of you. Let's give it another couple of minutes for people to come. I expect few more people to come in upcoming couple of minutes. I'm Iri. For those of you who don't know me, um, I'll be speaking about various ways how you can use machine learning and AI to improve your business. I will try to be, um, let's say, even when I am technical and I can implement such a things, I will try to be understandable and to explain those concepts in a way that will be approachable for people who are not software developers as well. But at the same time, I will show you some examples. You will see how those things, various neural networks and other concepts work. Before we will start, I would like to ask you, how did you learn about this webinar? Was it through Meetup, LinkedIn, Twitter, Meetup? Okay, great, great. Yeah, I know, Erland, you have been to the previous webinar. Daniel and Nina, are you new or have you been to the previous one? Okay, okay, good, good. There isn't going to be a large overlap. There will be new things. So even if you have been to the previous one, you will learn a lot of new things and you will see some new ways how to utilize machine learning to help your business. So all of you, can you see the screen well? Um, is the text large enough for all of you? Yes, yes, I hope so. Uh, okay, I'll try to make it as large as possible so you will see all the examples. Let's wait for 2 more minutes and we can start. Okay, okay. In the meantime, if you will have any questions, feel free to, yeah, wouldn't hurt. Okay, especially in terminal. Yes, just it is this size. Okay, I hope now it's large enough. Okay, okay. So let's wait for 1 more minute and we can start. We have 2 more people. I will also allow you to talk. So if you wanted to greet others or ask anything, in the end of the session, we will have a time for questions, but the chat will be enabled the whole time. So you can ask also during, especially if, for example, a text will be too small and you will not see something, or you will want to see something again. Please ask me, and I will show. For example, I will replay some training and so on again. Okay. So also, this session will be recorded and it will end up on our YouTube channel, youtube.com/@flexianadev. So if you will want the recording, it will be there. If you signed up through Meetup, or LinkedIn, or if you follow us on Twitter, we will post the link to the video when it will be edited, which might take about 1 week. The editor is sick now, so anyway, so let's begin. So hi everyone, thanks for coming today. And today I would like to speak about various ways how you can improve your business with machine learning and AI. Of course, I will be speaking also about large language models, which is what most of the people do and most of the people speak about nowadays. But I will be showing some other concepts. Those of you who have been in the previous seminar, you have heard about some of them, but there will be a new ones also. Quickly, some information about me. I am I'm a lifelong software developer. I started writing code as a child, and the whole my life I've been building systems. I started the company Flexiana, which is a software development company, and also we have a product Gitrivio, which is business intelligence platform for CTOs, IT managers, which is also using machine learning to evaluate productivity, to see what's happening in software development. Besides that, I have master degree in economics. One of my fields of study, which I really liked and I have spent a lot of time in, was operations research, which is a field of applied mathematics that's focused on optimizations. So some of those things I will be speaking about are very close to me, especially like when you look at the machine learning field. It begins with things that are very kind of low level, fast and simple, and then they go all the way to neural networks that are the most heavyweight. My experience is more on the other side, which is optimization tasks, simplex methods, and so on. So this is where I have some experience for machine learning with like building neural networks, training neural networks. It's something where I don't have that much experience. However, I do train neural networks. I will be showing you some. My first machine learning project was about 15 years ago. An example might be an optimization algorithm for personalization in e-commerce. Actually, I am working on such a project now as well. So basically, imagine e-commerce store that has plenty of customers, and you need to find what to recommend to individual customers, which surprisingly is mathematically quite a complex task because there is an insane amount of combinations to order products. I also implemented the first application that's using large language models more than 2 years ago. It's a tool for product managers, and prior starting the company, I was working as a CTO in a couple of companies. I was consulting. I was a mentor in a couple of startup accelerators. Originally, I am from the Czech Republic, but I've been living in English-speaking countries for a decade, so I might have an accent, but hopefully everything I will say will be understandable. Okay, so what are we going to speak about today? So first thing I would like to speak about are decision-making trees, which is in machine learning fields, it's a workhorse. It's something that's utilized a lot. And I will show you how these decision-making trees look like, how you can build your own decision-making tree if you have any data set, how you can use them. Then Paprika is an algorithm for decision making in fields where it is difficult to do an easy decision. It was let's say invented or discovered by Professor Paul Hansen, a friend of mine. who has been a professor of economics in the University of Otago in New Zealand. Hopefully next month, I will get him to speak on a webinar. So the founder of, or yeah, the inventor of this algorithm might be speaking on the next webinar. Then I'll be speaking about random forests, which is another form of machine learning, which is a not neural network, and it's great for building those decision-making trees. Then something that you have heard about from me are Kalman filters, which is extremely fast and lightweight way how to do some predictions, for example. For some of you, it will not be that new. Then we will speak about neural networks, about recurrent neural networks and Bayesian networks. Both of them have their use cases. We will be showing how they work, how they look like. Then we will speak how to implement those things in your company. And the last will be LLMs, which is large language models like ChatGPT, Anthropic, Claude, etc. Okay, we have more people here. Welcome. So let's begin with the first one, which is decision-making trees. So for decision-making trees, there are plenty of algorithms, and the most well-known and probably the most used is decision-making tree called C4.5. There is also a newer version, C.5. I will show you how these work, and you don't have to do, or you don't have to know any programming, any development, nothing like that. So basically, what is a decision-making tree? Decision-making tree is, imagine a situation where you need to create some algorithm or some way how to do right decisions, no matter if you are deciding, for example, or if you wonder, for example, you have a list of your employees in your company and you wonder who is likely to leave the company in the next 3 months. You have a list of customers, who is going to upsell, or for example, who is going to leave and move to your competitor. Or if you are in healthcare, today we will have more examples related to healthcare. So who is likely to get lung cancer, for example? So there are tools that are free, completely free, that allow you to build your own decision-making trees. So what I did was I generated a data set. Now, when you look at this data set, let's imagine we have an ice cream truck. And this ice cream truck is basically every day, it has certain weather. So let's say this day is cloudy, this day it's sunny, this day it's rainy. Every day might be different temperature, and every day there might be some event. So there might be no event, school events, festivals, and so on. And based on that, there might be some best position where the truck will maximize their profit, the revenues. And you want to create a decision-making trees to choose what's the best position, what's the best place. So let's say now we have some training set. So imagine you have that ice cream truck, and every day you write down the date, what was the weather, what was the temperature, if there was any event, where did you go, what was your revenue that day, and you want to train a decision-making tree for, sorry, for to decide for the future, where should you position your ice cream truck. So now let me tell you about the first tool. It's called Veka. Let me start completely from scratch. So I'll close the window right here. So Veka is a free tool. You can download it from the internet, and it is implemented in the University of Waikato in New Zealand. So it's a free tool. It's ugly. It's implemented in Java, so it looks a little bit different from the applications you know, but it's not so difficult to use it. So basically, what I did is I have a data set, commands, CS here. Now showcase, okay. And I have created a data set in a CSV file. So now I imported the data. So let's say you have some data in Excel sheet, any data about customers, colleagues, products, about anything. Now I already know that I need to remove this field, but I will show you. So basically I will, in here, I open file, then I move to classify, and I go to trees, and the decision-making tree I want to train is called J48. It's basically 4.5 algorithm. So I have to remove revenue, classify. Okay, and I want to predict the best position. Okay, and let's start. And now I got my decision-making tree. So what you see here, unfortunately, there is no easy way how to zoom this to make it larger for us. Yes, sorry for that. So basically, what you see here is generated decision-making tree. So if you have any data, as I said, about customers, about patients, about whatever, your competitors, and if you want to, for example, find what's the best step, what's the best treatment, what's the diagnosis, what's anything, you can quickly train your decision-making tree. So here, so if there is no event, event equals none, you will go to this level. Otherwise, I will scroll down. For example, if event is festival, and if day of week is Sunday, and if temperature is smaller than 21 in this synthetic data set, it's the best to go to the school, which of course, like at the school on Sunday, there will be no kids, but I generated more or less a random data set. If you had real data set with real like kids coming to school, it would not be Sunday. It would be, let's say, Monday to Friday. It might be the best to go to school. Saturday, Sunday, it might be the best to be at the stadium, where is the festival. So basically, this is how you can build this decision-making tree. If you have any programming knowledge, there is a good thing that you can basically generate a source code. So when I start the generation, I get my decision-making tree, but also I get a source code in Java. They basically contains this decision-making process here. So what you get is a part of the program which you can take and you can copy paste it in your application and it's done. It's not a lot of work. You can do it yourself. Even if you don't know how to implement applications, you can take this source code, you can ask AI to generate a simple application for you, and then you might have a form somewhere that will be generating, like you will fill the data. Okay, with my ice cream truck, today it's this date, it's this weather, it's this temperature, there are these events in my town, give me a recommendation where to go. And it will generate an application for you. So these are decision-making trees. The advantage is, as you have seen, training or building a decision-making tree is extremely fast, it's extremely simple. The disadvantage is that these decision-making trees might be a little bit too much overtrained for your data set, especially if you don't have that much data. If you have just like, let's say, 100 lines, it might give you predictions based too much on random situations. But I will be speaking about maybe a better solution now in let's say 10 minutes. Let me jump away from this and let me show you another interesting thing, which is let me jump to paprika. Let's go back to random forests in a few minutes. So paprika is potentially or pairwise ranking basically analysis, and it's a decision-making algorithm, and it's great when you have multiple options, and none of those options is the best at everything, and you have to decide if it's better A or B in this aspect, other aspect, and so on. With Professor Paul Hansen implemented a tool called 1000 Minds. I have no affiliate, I'm not paid. I know him for a very long time, maybe a decade, but I don't get like any payment for recommendation of this tool. So how does it work? So when you they have free trials. So when you sign into 1000 Minds, you can create your own decision-making process. But let's look let's look at examples. Okay, let me just sign in. Okay, so there are plenty of examples. So let's say we are interested in IT, and we want to prioritize IT project. So let's use example, copy example. And now let me explain you how this decision-making process works. So first thing is you have certain criteria, and these criteria have options like strategic alignment, low, medium, high, team expertise in a given thing, customer impact in given domain, innovation potential, and so on. So these are criteria. Then there are other considerations. You can also set impossible combinations. Then you have different projects. So basically, these are the options you are choosing from, and you set the attributes for each of those options. This can be used for anything: prioritization of projects, decisions on hiring, decision on the company structure, decisions on the company strategy. So you will list all the options you have, and then you will start training. So what you do is that you are always choosing between two options, and every time you choose between two options, the model it generates gets a little bit fast, a little bit closer, and a little bit more smart. So let's say, is it better to have a project with low strategic alignment but low complexity, or medium alignment, high complexity? So let's say this one. And as you can see here, we have learned the model is now trained from 2%. They have a feature that you can invite more people who can give their answers. So you can do it as a team, as an individual, or you can invite more people, and each of them will have their own weights. Okay, let's go. Okay, strategic alignment, high, customer impact, medium is better, customer impact, high, complexity, extreme is better. And as you can see, so let me just give a lot of answers. You can also say that these are equal, for example. You can say to skip certain question. And as you choose, you are training the model. And you don't have to finish. You can see the results in the meantime. So you can see here at the summary, and you will find out that it gives you the recommendation that your project you should prioritize right now should be AI-driven customer support, because it has high strategic alignment. Your team is proficient in this. etc. So you see all the options, you see them ordered. So this basically helps you to decide. Of course, as you are training those trade-offs, your models get even better. So until you will get to 100%, and once you get there, you go to results and you see, okay, so this option was the best, this was the second best, this was the third best. So so this is interesting algorithm. I have used this in the past multiple times. It's really this simple framework where you always compare two options and only two attributes in those two options. It's doable. Like when you are standing in front of very difficult decisions, this still is doable. You can always decide between two options and two attributes in those two options. And it gives good and sometimes surprising recommendations for me. So this is Paprika. Now let's continue in decision making, using machine learning to do decision making, and let's go back to let's say more technical stuff. And it is random forests. So as I was speaking about like decision making tree C4.5, as I said, this is super fast, super easy algorithm. You can even get the source code generated. There is application you can download. It's free. And then there is a level number two, let's say, which is random forests. Random forests are they know that they can do the same things. What is an advantage? They are very robust to noise and also to overfitting. How they work is that you don't have just one decision-making tree, but the tool. Again, there is a tool in the background for you that will do the training. It does not create just one decision-making tree, but it will create multiple decision-making trees, and it will run this training with your data subset. So let's say when we look at this data set, we have 500 lines, 500 data sets. So imagine we will generate 5 decision-making trees. So it will use, for example, first 300, then second 100 to 400, 300 to 500. That will take even and odd data set. So it will always use a little bit different data, and it will create multiple decision-making trees. And then when you want to create some, let's say, predictions, it will connect all those decision-making trees into one, and it will create something like average between those decision-making trees. And I must admit, I have seen multiple implementation of random forests, how good predictions it gives. I would say it's 100% comparable with neural networks. It's very powerful. It really works well in noisy environment. It's quite easy to train such a thing. Now, like if I will, I have trained a random forest here. Again, like it's small. It's just 86 lines of code to show you. It's the training part is actually just this, and basically if I will run this code here, okay, not here, okay, forest. So now the training is finished, and it has generated a decision-making tree. Now you can't see it all because it's too big. So now, as you can see, oops, it is significantly larger. This random forest, it's a little bit different. This is not trying to predict what's the best place to go. This one is trained to tell you for certain parameters what will be the revenues. So, for example, if weather is rainy or if it's not rainy. If it's rainy, if there is festival, if there is Wednesday, if there is January, if yeah, so true. So basically, if it's January, the revenue that day will be 465. Lots of these data does not make sense. Why would ice cream truck earn that much money in January? Please keep in mind I generated random data set, but this gives you a decision-making tree, and this is like you have a visualization here, but also you can take the source code, it's saved, the model is saved, and you can ask it to predict revenue. So let's say their week is Friday, so let's say the month is 6, the temperature is 25. I will run the model. Let's ignore this generated tree. It says, okay, my expectation is that predicted revenue, the day will be 68.71. So, so basically, this can be quite easily trained, and you can use this for various predictions of practically anything. What's the chance of customer leaving? What will be customer lifetime value, and so on. Okay, so these are random forests. So the biggest difference between random forests and C4.5 is there are tools. You don't have to program anything. It will generate it for you. It's very fast, but it might be overfitting for your data set. This is, in some ways, I would say, as good as neural networks. It's very robust. It requires a little bit of programming, but as you have seen, it's just like 50 lines of code, and it's simple. It's not that much. It's not that much programming. Okay, now let's speak shortly about Kalman filters. Is here anyone who wasn't on my previous webinar 1 month ago? I guess there must be at least 1 or 2 people who are new. So I was speaking about Kalman filters. So Kalman filters are predictions that are the fastest and the easiest ones. It's super easy. You basically take but it works in noisy environments. So imagine you have measures that are not accurate, and you have to take multiple measures and build predictions of the real state based on measures that are not 100% accurate. The advantage of Kalman filters is they are super fast. Like the fast is what you can get. And I have prepared, yes, I don't have it here, so let me open it. Okay, so if you can see my screen, every single blue dot is a measurement, and every single white dot is the real position, and it's the prediction. So now what you are seeing is, for example, 1,000 airplanes flying in the sky, and there are radars that are measuring. They are not 100% accurate. There is certain level of noise. Now, what you see here, it's running in the browser, it's learning as I speak, and it's not consuming any CPU at all. Like this thing is super fast and super simple. So it can run on a smartwatch, or if you have a product that has a very weak chip, microchip in it, it will run faster. So, but the disadvantage of Kalman filters is they expect linear behavior. They don't work well with deep state that goes a lot to the past. Like it's focused on immediate situation. So something that is focused on now, what's happening now. But for those things, it works well. Again, if I have shown you the source code, it would be just a few lines of code. And it's very fast. There is not much of the code inside. Okay. So it's the next one. Now we will be going from these like non-neural networks into neural networks. And one thing I would like to show you are recurrent neural networks. Recurrent neural networks are neural networks where the output is fed back into the neural network again, let's say in a cycle. It's a little bit more complex. Now there is something called a long-term short-term memory, which, yeah, its implementation detail, it's not important today. But basically what it does is that these neural networks are actually very good in predicting based on, let's say, past state. So let me, it was maintenance. Yes, it was, yeah. And I have two parameters there, train and predict. So let's use predict first, because I have already trained it. And then I will show you the training. So this is, imagine you have a factory. And in this factory, you have plenty of different machines. And all of those machines, like they have certain age in years. These machines have certain quality. They have certain workload. And there is some base interval. How often these machines should be maintained? Then you have the predicted, like how long the model expects that, how many days until the next maintenance, and what is the real date that should be spent for the next time it will be maintained. I have used some data set, I have trained it, I will show you, and this generated for me a prediction model which says, okay, was those estimates better than the base interval? Because what you want to do is you want to maintain the machines as, let's say, accurately as possible. And this model gave quite good, let's say, predictions for the maintenance, so the machine does not break. Because if you maintain it before it breaks, you don't have to stop the machine for repair. And this is the output of the model. Now, what I will do is I will run train, but we are not going to wait for the training to finish because it takes a long time. So I will continue speaking and we will get back to this. So as you can see here, I am training. It's a first run. There will be 50 rounds of training, and in every epoch, we will improve the model. So basically, the loss, what you see here, it's um, how far we are from the optimum, and it's squared. So for example, if the number here is 49, we are off by 7 days on average. When you see 30 or 25, we are 5 days. If you will see 16, we are 4 days off. So in each round of training, we are getting more and more accurate, and we are getting better and better prediction. And if you can see, this is quite slow. And now this training is running on M1 Pro CPU, and it's consuming, I believe, about 4 cores of my computer at this moment, like 100%. I think in the end, when it will finish training, you will see it was consuming something like 350% of my CPU. So 3.5 of the CPU is now running on the full power training the neural network. But as I said, we are not going to wait for the training to end. By the end, I will show you the out numbers. So let's say this is the recurrent neural network. So it's great if you have like data that go in time and you want to do prediction in time. Then I have created another neural network that not many people and companies use, but I consider it very interesting, and it's Bayesian neural networks. For most neural networks, when you feed them with some information, some input, they will give you one output. But Bayesian neural networks do not give you just one output, they give you multiple outputs. Basically, they give you the level of certainty. So you can ask, what's the chance, how much will this customer spend? But you can also ask, give me an interval with 75% certainty and give me an interval with 50% certainty. So what I did for you today, I have trained 3 models of Bayesian neural networks. I have wrapped them in one service, so it's running here. So this service is basically waiting for me to run simulations. And here I have created simple web applications. So it's 1, 2, and 3. It's here. So I can position them here, but so basically we have here accurate model, moderate model, and poor model. So each of them has got its training, and now we can run the simulation. So imagine there is a hospital and there are 2 doctors, eye doctor, pediatrician, and there is a waiting room. So, okay, so this is the accurate model. And here we have first patients, and now we have patients moving through reception, waiting room, treatment room, and discharge. Here we will run a moderate model, and here we will run a poor model. So now, if I would look here, my service is now being run and is asked to predict something. So this is now asking 3 different models to give me predictions. So let's look at that. And now we have 3 models. And as you can see this histogram, we expect that the model, like this is how much time individual patients spend in the, let's say, in the waiting room and in treatment in total against the estimate. So you can see the best model should be somewhere here around 0. This is error, -1 to 0 minute. This is 0 to 1. This is slightly worse model, and this is the worst model from all. So as you can see here, average difference is around, like, it's very close to, like, the average is very close to the 0, which means most patients get the estimated is close. Here, this model is now plus 0.8, let's say, so which means that people spend about 40 seconds more waiting for the treatment than expected. Here, patients actually wait almost 3 minutes less, but this is the mean, this is the central value. But what is also important is standard deviation, which means like how far the estimations are from the expectation. And as you can see here, we have those patients, and we have not only the estimate and the real time spent, we have also estimates with certain level of of certainty. So you can say, of course, this might be used elsewhere. It's not only hospitals. You can use it in, for example, a car shop. How long will it take to fix my car? And you can tell them like 75% chance it will be 17 to 25 hours, for example. So yes, this finished. We had 150 patients in this simulation. This is finished as well, and this is finished too. So as you can see, average difference, the best model was the most accurate. This was slightly worse. This was even worse. Standard deviation was the best here. Surprisingly, it's a simulation. It's based on random data. So actually, the medium model, the moderate model, had larger standard deviation than the worst model, which can happen. And if I rerun those three simulations, we would see different numbers. So as you can see, let me show you the Bayesian model, the training again here. So this is the app and this is training. So the training, the whole training is just 280 lines of code. It's not big. And you have, I would say, quite practical feature that allows you to estimate things and to also give levels of certainty. This is something that I have a company, I am asking people for estimates all the time. And sometimes the estimates are off a lot. Having something like this in repeatable processes where you have a lot of data, you don't have to ask for estimates. You can train the model. It will give you estimates. It will give you the level of certainty. You can draw charts that will give you an expectation, like you can see what you can expect then, like let's say how much you will spend for a certain feature to be built or a certain product to be made. Okay, so did we finish the training already? Yes. So as you can see, we finished training here. It took us about 5 minutes. I forgot to add one time. 1 second. So in the background, I will run it again. We will speak about other things. Sorry. Dictation feature. Okay. So it's training now. And let's go back to my presentation. It will be training, and later we will see how much time it took for the training. Okay. Now, how to implement those things in your business? So first thing I would like to say is do not be afraid of machine learning. It's a complex field. It's big, but it's approachable. There are tools, as I said, there are tools that are free. And there are plenty of books, tutorials. You can use LLMs, you can chat with ChatGPT and learn about it. You can ask people to help you with implementation. Very often, as you have seen, it's something between 50 to 250 lines of code. So it's not that bad. Then you need to decide what you want to automate. So one option might be the automation of some decision making, like what to do next, where to spend money, and so on. The second is classification. So you might have some data you want to find out which customers are rich, which customers are most likely causing some fraud or misusing your product. Predictions. So based on certain inputs, you can predict certain outputs. Those inputs might not be only numbers. As you can see, or as you have seen, the inputs might be qualitative data, like there is an event in my town, what is the impact of this event in my town on my business or on something. Then you can use machine learning to generate things like large language models. It's generative AI, but there are other ways how to generate data. This can be used, for example, for testing things and so on. Then you need to collect data. Data collection is not an easy thing, to be honest. I think to do proper machine learning, having 100 items or less is probably not going to give you a good model. So this might be the biggest obstacle, is not having enough data, not having data in a good shape. Then once you have the data, it's better to first do some prototype and to validate your idea that it works, because you have seen those models I have shown you that in general they worked. They can be improved. So there is an interesting article I have read a couple of days ago, and it shows the validation. It's called "The Closer to the Train Station, the Worse the Kebab." So the author saw a hypothesis on Reddit: the closer to the train station, the worse the kebab. So that's a theory, and he decided that he will validate that the theory is true. So what he did, he mapped out data. I think it's Paris. Yes, it's Paris. He loaded the location of all train station or metro station, like all public transports. He pulled data about all restaurants. He split the map into regions and calculated the distance between each restaurant and train station, each restaurant that serves kebab from Google Maps. And then he cleaned the data, calculated the distance, and he got some results. So this is rating in stars on Google Maps, and this is the distance from the restaurant. And then he calculated, thanks for coming, Pen. Hopefully see you in the future. So what he did, he calculated this data set, and he got a correlation, which is a metric of relationship between two attributes, which was 0.091. Basically, what correlation is, if it's 1 or close to 1, the relationship is super strong, like even 0.8, it's super strong relationship. 0 means no relationship at all. And negative means the more something grows, the more the value of the second thing decreases. But basically, correlation around 0 means no relationship. So the output or the outcome, he did 2 more improvements of his data set, and he ended up with coefficient 0.001, which means he proved that there is no relationship between the rating of the places that serve kebab and the distance from metro station, railway station, and so on. So basically, this was an example of how those like machine learning, this is like a form of machine learning. Statistics is a form of machine learning when you use machines. So he validated that this idea is not true. So this is how the validation of your idea might look like. It's a simple prototype. It's one of source code. In the end, he got some coefficients and he decided, okay, the relationship is not there. But when you validate the idea, it tells you, okay, it might work. So then you integrate the outcomes, you integrate the model into your application. So that's the next step, but you already know it works. Okay, so these were things I wanted to speak about that are not related to large language models. I would like to show you a few examples of integrations of large language models that we are now doing, or we are analyzing, and we will be doing in near future. And these seem to me to be like interesting and a little bit non-traditional ways how to use large language models. So first is adherence to standard operating procedures, basically to processes. So as I was speaking about Gitrivia, the application business intelligence platform we built for CTOs, IT managers, team leads, and so on. One of the things that is time consuming, super boring, no manager likes doing them, is constantly checking if the team is doing the process as agreed. Like you might have, let's say the team will decide that all tasks will be split to be no more than 16 hours. And let's say the team over time, they start spending maybe 20 hours on some tasks. Later, it might be 20 plus hours on majority of the tasks. And if the team lead or manager is not constantly checking what the team is doing, they might be breaking the process for a very long time. So what you can do is you can feed your company processes into large language model, and you can feed it with behaviors of teams or individuals and ask LLMs to find behaviors that are breaking the standard operating procedures, and to isolate all things that are off. And then you get a list. For example, what we do, we use SendGrid to send email as a service. You can easily call the API. It sends beautiful email. It doesn't fall to spam. It's good for various notifications. And so send an email. It ends in the mailbox of, let's say, a team lead, and it will say, hey, the name of the team lead, for example, IT manager. I noticed that this procedure, like to run tests before you will deploy to production, make sure that cyclomatic complexity of the code is not larger than something. Time spent on a task will never exceed 20 hours. If yes, the task should be split to two. Was broken this date, these tasks, and so on. So they can go and they can address it. So if we are doing this evaluation every couple of hours, it's still a fresh situation, so the manager can go to the team and resolve it. The second thing is clarifying outliers. So again, what we do in the tool is we are measuring not only those like qualitative things, but also quantitative measures, which might be people are committing every day. The team is pushing every week or a couple of times per week. The test coverage is certain percentage. All of those things might be um, let's say having outliers might be okay. You might have a team that for some reason will do no commits, no releases for 2 weeks, or you might have a team that does 15 releases in one day. This might happen. This has happened to me. What it means is it's not automatically bad, but it's something that some manager should resolve, should know about, and should speak about with the team and see what's happening. So now we might be feeding, let's say, the numbers, all numbers, like over time, we do this amount of releases, for example, of a new version of the product. And now we have this amount. So there might be an outlier. And LLMs are quite good at looking for outliers, especially if you mix qualitative and quantitative data. If you have just quantitative data, which is numbers, it's easy. You don't need LLMs. You just create some rules, like you have an outlier that's 20% outside of your moving average, and alert me. But when you, for example, want to add some, like, if it's Friday and you release more than usual on Friday, alert me. So these are the things you might be told about by LLMs. And every morning you will get an email with outliers to your inbox. Then the next thing is processing feedback. So if you have some channels where people speak about your product, where they speak about your company, you might use these tools to scan internet for you and look for new feedbacks and collect them somewhere. I was playing with a tool called Crew AI, which is again, it's if you know programming, you can download it for free. You can build your own agents, and they can search internet. There is, for example, DuckDuckGo search engine. So you can create an agent that's scanning internet for people speaking about your product, people speaking about your company. You can collect the data and automatically data mine the sentiment. So do people speak positively, negatively? Do people have any problems with your product and so on? So this is an agent that works for you, and you can run it every hour. You can save in the database all pages you have already seen, so you can skip those pages. Those tools or those agents can use different tools. If I will go down to documentation, there is quite a lot of tools Crew AI can use. So basically, you can search in Google, you can search with DuckDuckGo, you can save data to database, and so on. So and it's a code. So if you know how to build applications, you can integrate it with any Python library, and it will work quite easily. So so this is another good option how to utilize large language models in your company, and it will work automatically for you and give you some inputs. And the last one is it the last one? Yes, it's the last one, suggesting priority changes. So if you have been to my previous webinar, I was speaking about blow-up factor. I don't want to spend too much time speaking about blow-up factor. Again, you can watch it on YouTube. But basically, what I want to remind, basically all projects, more or less, are distributed in log normal distribution. So this is the estimate. And the real time spent is usually around the estimate. Let's say there can be time, let's say some constant, times 3 very often. So let's say you expect it to be 0.3 weeks. In real world, it will be around 1 week, but sometimes it's half of the week, and sometimes it's 2 weeks. It's sometimes like the right leg is usually longer than and you can't go under 0, right? It's a boundary you can't cross, but the right side can potentially go to infinity, that you will never finish the project. The log normal distribution is a reality of how long projects take. And you can use large language models that are aware of this. So if you will feed them with the data to tell you, like if you will feed it with work being done, it can estimate the percentage of how much is finished. You can feed it to the algorithm that will calculate the log normal distribution, which means it will give you an estimate what's the percent that it will be finished in certain time frame. And if you know how much you want to spend on certain project, you know if you should stop or deprioritize the project and so on. So actually, LLMs can tell you, hey, you are spending too much money on this. It's not likely that you will finish in budget. And so this is great. As you can see here, one of the things I wanted to say here, I have told it last time, I tell it today, I will tell it next time. LLMs should use tools. They should have access to other systems. So when you look at, I don't know, this one, SOPs, LLMs here have access to tasks, to work reports, and are able to send emails. Here, the tool has access to our business intelligence platform, and LLMs can send emails. Here, LLMs or agents, but LLMs can search internet, can process data and save them in the database. Here, LLMs can see reports of the work being done, budgets, and they can give you recommendations. LLMs, when they are using tools, might really become agents that are doing things for you, especially if you really like make some simple tools. For example, those like blow up factor things I described here, and I have explained them in a big detail in the previous, so it's on YouTube, on a previous presentation. These are simple tools that can give a lot of advantages, a lot of good things. Okay, key takeaways. Overall, I would say machine learning is underused, given it is complex topic, but it's approachable. It's doable, and you can do it. If you have any basics, there are things you can do even when you don't know how to program applications. Like, for example, when I was showing you Abeka from University of Waikato, I don't know if I pronounce it correctly. These are the tools that are for free. It's not pretty, but it works. They have plenty of algorithms there, actually. Like when I was, yeah, it would take a while. Anyway, so for example, those classification, you can cluster data, associate data, you can visualize things. So this tool can do a lot of things for you, and it's free. Okay, I would like to thank you. It was a privilege to have a chance to show you some things that I think are interesting and helpful for people. There is my email. There is also our YouTube channel. There will be a recording on that YouTube channel. So hopefully I will see you there on the next webinar. As I said, I would love to get Professor Paul Hansen next month to speak about Paprika, about the decision making tool I was showing in the beginning of this presentation. Okay, great. Thank you very much, and see you again.